Neeraj Kumar, can you hear me? Hello.
Yes, sir.
Okay, so we
You
will
are
wait for. Yes.
you are audible, sir.
Okay, so we will wait for a few minutes more for other students to join, and then we will start at 7:10.
As you like, sir.
So you can see my screen. I have currently shared a presentation.
Yes, sir. Visible,
Okay.
sir.
Okay. Thank you. Thank you for confirming. Thank you.
Okay, sir.
Hello everyone, a very good evening to all. Can you all hear me?
Yes, sir.
Yes, sir. Good,
Okay,
good evening,
so
sir.
very good evening. So let me first introduce myself. So I am Vivekananda Naik. I am a PhD research scholar in the Department of Energy Science and Engineering at IIT Delhi. So basically, I am a PMRF TA of this course. So as a part of my course duties, I will be taking live interaction sessions. The session is scheduled on each Monday, and the timing will be the same like today, 7 p.m. to 9 p.m. So in these live sessions, I will be discussing a few problems that will be based on the course lectures that the current week's course lectures, and also if you have any doubts regarding the course content or any concept, you can ask me. So I hope it will more or less say as the name implies. So we can interact more through this platform. It is an it is a great initiative basically from NPTEL, which will help you to interact directly with me. So, uh, so let's start with the session. But before starting the session, I will like to give a few details about the session. So, as we all know, the name of the course is Atomic and Molecular Physics, and it is being flowed this semester by NPTEL with the course code NOC 25PH04. The course coordinator is Professor Amal Kumar Das from IIT Kharagpur. So, so these are the details of the interaction sessions. So this is the meeting link. I hope the meeting links you have been already provided with the meeting links through the mail from NPTEL also. And although also if you are not being able to join through the meeting link, so these are the details. An alternative way to join in the meeting. So meeting ID is 422-188-062-091, and this is the password. And similarly the session timing is every Monday from 7 p.m. to 9 p.m. So this is the today is the first session, and I'll be taking in a total of 12 sessions, which will cover 12 week course contents and an extra interaction session for 1 hour or 1.5 hours, where I will discuss overally the concept of the course, which will help you to get a complete revision of the course, basically what you all read in this course. So let's start with the uh, with our discussion. So basically in the week one of the lectures, main concept that were discussed in the week, let me first briefly tell the contents of the course. So the course week one lecture content of the course is mainly related to the experimental observations and theoretical developments of the constituents of the atom. Basically, it covers a few experiments that helped in discovering the atomic particles like electron discovery was done, and then Rutherford's alpha particle or Goldfall experiment that helped in discovery of proton. Then Newton was also discovered by James Chadwick, and then the experiments like Faraday law of electrolysis, then Thomson's experiment. Thomson's experiment, basically from Thomson experiments, electron was invented or sorry discovered, and then uh, there are also Millikan's oil drop method and other experiments that helped in determining a few things like uh, as we as you must have been already introduced to the course, uh, Faraday law helped in understanding the constituents of atom in some aspect. Then through Thomson experiments, we got an idea about the charge by mass ratio of the electron, and then from the Millikan's oil drop method, we found out the charge of the electron. Then from charge by mass, we can also calculate the mass of the electron also. So we will solve a few problems that will be covering this concept that you have read in the week's course, week's lecture. So do any one of you have any doubt? Yes. Okay. So we will start solving the questions that will cover the week's content. Question number one. The question says the quantity of electricity required to liberate 0.2 gram equivalent of an element at the electrode is option A 9650 coulomb, option B 96500 coulomb, option C 965 coulomb, or option D 19300 coulomb. So these are the four options. So, and the question says the quantity of electricity required to liberate 0.2 gram equivalent of an element. It is not 0.2 gram of an element, it is 0.2 gram equivalent of an element at the electrode, and these are the options, option A, B, C, and D. So I'll give you a few minutes to think about this question and try it, and then we will discuss how we will solve this question. So can anyone tell me what will be the correct answer?
Option D.
Okay, so how do you solve it?
Because 1 gram of equivalent to liberate it, we require 1 farad of current, which is 96500 coulomb. So for 0.2 gram, we'll just multiply 0.2 by it and we'll get 19300 coulomb.
Okay. Okay. Yes, it's absolutely correct. So basically, this question is based on Faraday law of electrolysis, and according to that law, the amount of substance deposited at the electrode is directly proportional to the current, total charge passed to that system. So according to the law, M is directly proportional to Q, where M is the mass of the substance deposited at the electrode, and Q is the amount of charge. So, so here the if you introduce the proportional constant, it is M will be direct proportional to Q, or M is equals to Z in Q, where Z is the equivalent weight of the substance, equivalent weight of the substance, and the expression is total weight by valency or charge. We can say V, or so total weight by valency. So now if you talk about the definition of 1 Faraday, so 1 Farad is the amount of electricity required to deposit 1 gram mole of element at the electrode. So, and we know 1 Farad is how much? 1 Faraday is equals to 96,500 coulomb. 96,500 coulomb. So, if we pass 96,500 coulomb of electricity through the electrodes, then 1 gram mole or 1 gram equivalent of the substance will be deposited. But in our question, it is given the quantity of electricity required to liberate 0.2 gram equivalent of the substance. So, in order to, so this 1 Faraday will be used to liberate 1 gram equivalent of the substance. Now, in order to liberate 0.2 gram, we will multiply 0.2 with this 96,500 coulomb. So, the answer will be 0.2 into 96,500, which is 19,300 coulomb. So, this is the answer, and correct option is option D. So, the correct the quantity of electricity that is required to liberate 0.2 gram equivalent of element at the electrode is 19,300 coulomb, because in order to liberate 1 gram equivalent of that element, the amount of electricity required is 1 farad, which is equivalent to 96,500 coulomb. I hope this is clear to everyone, or is there any doubt in this question? Okay, so if there's no doubt, we will proceed to the next question. And the question says, during the electrolysis of molten sodium chloride, the time required to produce 0.25 mole of chlorine gas using a current of 5 ampere is, where we have to take 1 farad is 96,500 coulomb, and the options are option A 96,500 second, option B 9,650 second, option D 4,825 second, or option D none of the above. So, question says, during the electrolysis of molten sodium chloride, the time required to produce 0.25 mole of chlorine gas using a, so here this is chlorine gas using a current of 5 ampere. So we can take, suppose this is a electrolyte is present here, and then there are two electrodes, and then we are applying some voltage, so the current passes to the electrode. Now this is molten sodium chloride, and the time required to produce 0.25 mole of chlorine gas. So we need to produce 0.25 mole of chlorine gas. So chlorine gas means it is not Cl, it is Cl2, because chlorine gas is diatomic in nature. So we need to produce Cl2, and it is 0.25 mole of Cl2, and the current is given to us. The amount of current which needs to pass is 5 ampere. So the current is given, I is 5 ampere, we need to find out the time required. So what is the required time we need to find out? So the options, these are the options. Option A 96,500 second, 9650 second, or 4,825 second, or none of the above. So I'll give a few minutes to try this question and then we will discuss what will be the correct option. So I just posted a question on this Q&A section of this team. So can someone confirm me, or any one of you can confirm whether they can they are being able to see that question? Like I have posted something in the Q&A section of this teams.
Sir, where is the Q&A section?
So you are using mobile phone or desktop or any other device?
The desktop.
So so when you are appearing, so your screen must be appearing na. So there are menus like chat people, Q&A, react, all these things. So can you see the menu of Q&A? Okay, if it's not appearing, then leave it. You continue solving the questions. I was just trying to see whether this feature is available to all of the students. Then we can communicate through this section also. So that is the main issue. But it's okay if it's not being visible. So we can leave it. It's not that much important. So can anyone tell me what will be the correct answer?
Sir, option B.
Okay, so any other? Anyone? Okay, so the question was during the electrolysis of molten sodium chloride, what is the time required to produce 0.25 mole of chlorine gas using a current of 5 amperes, where 1 farad is 96,500 coulomb. So now, uh, what is the weight of chlorine gas?
The 71.
Yes, so chlorine gas is Cl2. We know the mass of chlorine is 35.5, or mass of 1 gram of chlorine, we can say it is 35.5 gram, or sorry, gram mole. Then for chlorine it is 35.5 mu. So for Cl2 the weight is 71 gram, or 1 mole of chlorine, 1 mole of Cl2, the weight is 71 gram. Now we need to produce 0.25 mole of chlorine. So 0.25 mole of chlorine is equals to 71 into 0.25, which is 17.75 gram. Now we need to find out what is the amount of electricity we are passing through the electrolyte, the molten sodium chloride, so that this 17.75 gram of chlorine will be liberated at the electrode. Now, if we talk about the equivalent weight of chlorine, so what is the equivalent weight of chlorine? Equivalent weight of chlorine. So now in NaCl, it is produced from Na plus and Cl minus. So here chlorine carries only one charge, 1 unit of negative charge. So the equivalent weight of chlorine Z, so ZCl is the weight of chlorine by the valency. So it is 35.5 divided by 1, which is 35.5 gram. Now we know, according to the Faraday law of electrolysis, the equivalent the amount of mass is equals to equivalent weight into total charge. So we know Q is equals to I into T, charge is equals to current into time. So we have the value of current. Current I is 5 ampere, and we need to find out the time. So T will be, so from this equation, if we put T will be how much? So if we put in place of Q, if we put Q equals to I into T, so T will be how much? T will be M divided by Z into I. So M is, what is the mass? It is 17.75. 17.75 divided by what is the uh, value of, so it will be M. So now, sorry, one F will be considered here now in Faraday. So it will be MF, because for 1 gram equivalent we need 1 farad of electricity. So it is MF by ZI. So 17.75 into F is 96,500 coulomb, because in the question it is mentioned that take 1 farad is 96,500 coulomb, divided by Z. Z is 35.5 into 5. So if we solve it, it will give you, so now this is 17.75, it will be 2, so it will be 96,500 by 10, which will give you 9650 seconds. So This is the correct answer. So so in order to produce 0.25 mole of chlorine gas, if you are using a current of 5 ampere, we need 9650 seconds if we are doing the electrolysis of a molten sodium chloride. So what we did, we know in order to produce 0.25 mole of chlorine gas, we need to find out what will be the weight of 0.25 mole of chlorine gas. So uh, since chlorine is a diatomic molecule, so it will be Cl2. Cl2 means the mass of the chlorine gas will be 35.5 into 2, which is 71 gram. Then now we have to calculate the equivalent weight, because in order to produce that much amount of chlorine, we need to determine the equivalent weight of the chlorine, because this chlorine gas will be formed due to the electrolysis of this molten sodium chloride. Now, if you consider the molten sodium chloride, in case of molten sodium chloride, the constituents of NaCl is Na plus and Cl minus. So here the valency of chlorine is 1. So the equivalent weight of chlorine will be 35.5 divided by 1, which is 35.5 gram. Now, according to Faraday laws of electrolysis, we know 1 gram equivalent. In order to deposit 1 gram equivalent, we need 96,500 farad in 96,500 coulomb. So, what will be the amount of charge required to produce 0.25 gram mole of equivalent? So that will be IT. So this IT is the product of current and the time. So the value of current is given to us in the question. It is 5 amperes. So we can calculate the time period, the required time period to produce that 17.75 gram of chlorine gas at the electrode. So I hope this is clear to everyone. Or is there any doubt in this question? Okay, so we will move to the next question. The question says, question number 3: how much aluminum would be precipitated in an if an aluminum chloride solution is electrolyzed for 965 seconds with the current of 10 amperes? Options are: option A 2.7 gram, option B 3 gram, option C 0.5 gram, and option D 0.9 gram. So this is pretty much similar to the previous questions that we have discussed. So it should not take much time. So please solve it and tell me what will be the correct option. Yes. So can anyone tell me what will be the correct option?
Option D.
Okay, so the correct answer will be option D, that is 0.9 grams. So if we solve it, we know 1 farad of charge is required to liberate 1 gram equivalent weight of the substance. So in AlCl3, you know the valency of aluminum is 3 and the valency of chlorine is 1. That's why the compound AlCl3 is forming, that is aluminum chloride. So now from this aluminum chloride solution, here it is given how much aluminum will be precipitated. So in order to found the amount of aluminum that will be precipitated, we need to calculate the equivalent weight of aluminum. So the equivalent weight of aluminum, so what is the atomic mass of aluminum, atomic weight?
So 27.
So it is 27 divided by valency. Valency is 3, so it is 9 grams. So the equivalent weight of aluminum is 9 grams. So in order to liberate 1 gram equivalent, we need 1 farad, that is 96,500 coulomb of charge. Now if we are passing a current of 10 amperes for 965 seconds, so what is the total amount of charge? So charge is I into T, so it is 10 into 965, which will give you 9650 coulomb. So 9600, so 96,500 coulomb charge liberates 1 gram equivalent of aluminum, which is 9 gram. So 9650 coulombs, 9650 coulombs will produce 9 divided by 96,500 into 900, 650 grams. So it will give you 0.9 gram. So 0.9 gram equivalent of aluminum will be liberated if we are passing a current of 10 amperes for 965 seconds. So the correct option will be option D, that is 0.9 gram. So here the correct option was 9650 seconds. So the correct option is option B, 9650 seconds. So I hope this is clear to everyone. Or if there is any doubt, anyone can ask me. Otherwise, we will move to the next question. Okay, so I think we should move to the next one. The question says the mass of a substance deposited in electrolysis is numerically equal to twice the electrochemical equivalent when a current is passed through the electrolysis or electrolyte for 5 seconds. Find the value of the current. So again, this question is related to Faraday's laws of electrolysis. The question says the mass of substance M is deposited in electrolysis is numerically equal to twice the electrochemical equivalent Z. So the mass of the substance deposited is 2 times the electrochemical equivalent Z. So we need to find out what is the value of current that if it passes through the electrolysis electrolyte for 5 seconds will liberate this much amount of material, that is twice the amount of equivalent weight of the substance. So the options are option A 0.4 amperes, option B 1 ampere, option C 2.5 ampere, and option D 4 amperes. So these are the 4 options. I request you to try these questions and then we will discuss what will be the correct option. So can anyone tell me what is the definition of 1 Faraday?
1 Farad is the amount of charge required to deposit one equivalent mass of a substance.
Any other definition? That's why, because that definition we have already discussed. Any other definitions? Is there anybody who knows? So in otherwise you can say 1 farad is equivalent to the amount of charge carried by 1 mole of electrons. So if you calculate, we know the charge of electron is 1.6 into 10 to the power minus 19 coulomb. So if you multiply that with the Avogadro's number, that is 6.023 into 10 to the power 23, so you will get the value of 96,500 coulomb. So basically 1 farad is the amount of charge contained by 1 mole of electron. That's why if we are passing 1 coulomb of charge, one farad of charge, that's why their 1 mole of or 1 gram equivalent of that substance is getting deposited. So you can calculate and verify on yourself. So we know the mass of, sorry, the charge of electron is how much? So 1 Faraday equals to E into Na. We know the charge of electron is 1.6 into 10 to the power minus 19 coulomb, and Na is Avogadro's number, which is 6.023 into 10 to the power 23 per mole. So 1 farad is 1.6 into 10 to the power minus 19 into 6.023 into 10 to the power 23. So if you multiply it, you will get 96500 coulomb per mole. That's why the unit is also coulomb per mole. So 1 farad is equivalent to the amount of charge carried by 1 mole of or Avogadro's number of electrons. So now coming to the question, can anyone tell me what will be the correct answer?
Sir, option A.
Okay, so option A means it is 0.4 amperes. So yes, option A is correct. So we know according to, so here we don't need to consider all these farad values, because here it is already given the mass of the substance is equal to the electrochemical equivalent. So since the mass is equal to the twice of the electrochemical equivalent, we don't need to consider any Faraday term or Faraday factor here, because the mass and the electron chemical equivalent are both in same units. That's why we don't need to consider the Faraday term. So very simply we can write according to the law of electrolysis, M is direct proportional to Z, or M equals to, sorry, M is direct proportional to, 1 minute. So M is direct proportional to the amount of charge. So M is ZQ, or Z into I into T. Now in the question is mentioned M is twice the amount of Z. So it is, we need to find out the current. So the current I is M by ZT. Now M is 2Z, because the amount of mass is deposited is numerically equal to twice the electrochemical equivalent. It is given in the question. So 2Z divided by ZT. It is so ZZ will get cancelled out. So 2 by T. T is how much? T is 5 seconds. So 2 by 5, it will be 0.4 amperes. This is 0.4 amperes. So the correct answer is 0.4 ampere, that is option A. I hope this is clear to everyone. Now we will move to the fifth question. The question says, or is there any doubt in the previous question? Okay, so we will move to the next one. The question says a charged particle of mass 0.1 gram and a charge of 10 to the power minus 4 coulomb is thrown at an angle 30 degree from a point A with the speed of 20 meters per second in a region where there is no gravity force. However, a uniform electric field of magnitude 10 volt per meter is acting downwards. So in that region as shown in figure. Now we need to find out, we need to calculate the maximum height attained by the particle, and the options are option A 0, option B 5 meter, option C 10 meter, or option D 12.5 meters. So let's understand the question. So the question says there is a particle of mass 0.1 gram. So there is a particle here at point A. Now this particle has a mass of, so this particle has a mass of 0.1 gram and charge is 10 to the power minus 4 coulomb. Now this particle is thrown at an angle 30 degree from point A. So at an angle 30 degree means the initial velocity of the particle is 20 meters per second, and it is directed at an angle 30 degree when compared to the horizontal position, that is this ground. So the angle between the direction of particle of motion of the particle and the ground is 30 degree. So this angle is 30 degree, and the initial velocity with which it is being projected is 20 meters per second. Now in between A and B there is a electric field region. So the electric field region, so this is a uniform electric field region. Uniform means at all these points, at the regions where the particle is traveling, the electric field remains the same. So the value of the electric field is how much? It is 10 volt per meter. 10 volt per meter. Now we need to, however, if you see, if we are if you are throwing the particle in upward direction, however the direction of the electric field is downward. So and also the particle that we are throwing, it has some mass and some charge. So due to that charge and due to some mass, it will experience force. So due to the mass, it will experience the gravitational force or downward force. Again the same force here. So because in the question you see it is given where there is no gravity force. So since no gravity force we need to consider, we will only consider the electric field, the force due to the electric field, and the force due to the electric field only comes due to the charge, because only a charged body will experience some force in the electric field, otherwise it will not experience any force. That's why, because there are two things, one is mass, another is charge. Due to mass it experience gravity force, and due to charge it will experience the force due to electric field. But since will it is mentioned that there is no gravity, so we will consider only the force acting on the particle due to the presence of electric field only. Now we need to find out what is the maximum height it can attain. So since why the question is like this, because since the particle is moving in upward direction and the force is acting in downward direction, so this force will oppose the motion of the particle. So after some time the motion of the particle will be stopped, and that is the maximum height it will travel, and then due to the direction of the force it will again travel back towards the ground, or towards the line AB. So the options are option A 0, option B 5 meters, option C 10 meters, or option D 12.5 meters. So this is a good question. These type of questions you will face if you are appearing for the exams at the end of this course duration. So I'll encourage you to try and solve this question. So I'll give you a few minutes to try it, and then we will discuss what will be the correct option. So did anybody solve it? Okay, so we will. So can anyone tell me how we will approach this problem? Yes, anyone? So okay, so let's discuss. So now the question you see, the question says that there is a charged particle which has a mass of 0.1 gram and a charge of 10 to the power minus 4 coulomb. Now here the particle is thrown at an angle of 30 degree with an initial velocity of 20 meter per second, and the particle moves in a field, in an electric field region having a magnitude of 10 volt per meter. So now you see, according to the equation of motion from kinetic theory of motion, then the one of the equation is v square is equal to, so v square equal to u square plus square is equal to u square plus 2as, is not it?
Sir, it's plus.
Sorry.
Sir, you have written minus 2 years.
No, I have written plus. I think there is some issue in the connectivity. So v square is equal to u square plus 2as. But now you see here we will be calculating the maximum height, that is the height in the vertical direction. So this is the vertical direction, but the force that is being applied on the particle is in downward direction. So that's why here A will be negative, because the acceleration or the force or the acceleration which will be which is a cause of the force that is acting, the force is acting in opposite direction, so it will be a retarded motion rather than being a accelerated motion. That's why the particle will, after traveling for some time, some distance, it will stop and then it will move in opposite direction or it will fall. So now if we consider, so when it attains the maximum height, then the particle will be at rest, because at that point then from beyond that point it can overcome the acceleration that is opposing its motion, and then it will fall or it will move in opposite direction. So before moving in opposite direction, it will be coming to the rest. Then so we know v square is equal to u square plus 2as, but here a will be negative, so we can write v square is equal to u square plus minus 2as. Now when s, we know s is the distance, so s is h, or this is the maximum height. So after reaching the maximum height, the velocity will become 0. So at that point v will be 0, because it will change its direction, and we know u is the initial velocity, which is 20 meter per second, 20 meter per second. But now you see, here we are talking only about this. If we are talking about the distance s, we are only talking about the vertical distance that is in y direction. So this is x direction and this is y direction. So in order to find out the distance traveled in y direction, we need to find out, or we need to calculate what is the velocity of the particle, initial velocity in y direction. So we know for any vector, if this is the resultant and this is the angle theta, and if we resolute the components, then this component will be cos theta and this component will be sin theta. If its value is r, then it will be r cos theta and r sin theta. So here r sin theta is along y direction and r cos theta is along x direction. So the component of velocity here, it will be uy, which will be u sin theta, that is 20 into sin theta. Theta is 30 degree, it is given in the question. So it is sine 30, that is 20 into 1 by 2, which is, so this will be 20 into 1 by 2, that is 10 meter per second. So the velocity or the initial velocity of the particle along y direction is 10 meter per second. So now we can solve this equation. So now this is 0 because at the point of maximum height v is 0. So u will be, sorry, so u square will be 2as, this is square not z, then s will be u square by 2a. Now u, we have u is here, u is nothing but uy. So ui is 10 meter per second, and then this is 2 into a. Now what is the value of a? We know if a particle is moving in an electric field, the force acting upon that particle due to the charge will be QE, and this force is equivalent to mass into acceleration. So what is the value of acceleration? So it is QE by m. The charge is given to us, the mass we also know it is 0.1 gram, and the value of electric field is given to us. So a is how much? Q is 10 to the power minus 4 coulomb. 10 to the power minus 4 into electric field strength is 10 volt per meter divided by mass of the particle. Mass of the particle is 0.1 gram. So the unit is the most important factor when you are solving a numerical question. So since all these units we are taking in SI units, so we will convert gram into kilogram. So 1 gram will be 0.1 into 10 to the power minus 3. 0.1 into 10 to the minus 3 kilograms. So if you calculate, A will give, what is the value of A? A will be 10 meter per second square. So the acceleration due to the electric field applied is 10 meter per second square. Now we have already taken the sign negative in the question while solving, so we will take only 10. We won't take minus 10. Then S is u square by 2a. So h will be u square, u as 10, so it will be 10 square divided by 2 into 10. It will be 100 by 20, that is 5 meter. So the correct answer is 5 meter. So after traveling a vertical distance 5 meter, the particle or the projectile will come at rest, and then it will reverse its direction of motion. So the distance or the maximum height attained by the particle is 5 meter. So the correct option is option B. So is this clear to everyone?
Yes, sir.
Okay, so I hope you understand this question, because these types of questions you will get in the exam. And now we will move to the next one. So, however, let me discuss this question once again, because this is an important question. So the question was, what will be the maximum height the projectile travels in an electric field if it is projected at an angle 30 degree from the horizontal direction with an initial velocity of 20 meter per second. The particle has a charge of 10 to the power minus 4 coulomb and a mass of 0.1 gram. Now, if you consider the equation of motion, then one of the equation is v square is equal to u square plus 2as. Then, however, here if we are considering the vertical distance, the electric field is being applied in another direction, and the particle is moving in exactly opposite direction. So the electric field is being applied in minus y direction. However, the particle will move in plus y direction to get some height or to attain some vertical distance. Then we will take acceleration as negative. So if we are taking acceleration as negative, this equation will become v square is equal to u square minus 2as. But if we are talking about the maximum height, after reaching the maximum height, the final velocity will be 0. So we will take v is equal to 0. And if you calculate the velocity with which the particle is being projected, it is the initial velocity, and this initial velocity is the velocity of the particle along the y direction. So we need to resolve the resultant velocity value. So the component of the velocity acting along y direction or acting along the direction of motion is uy, because since the particle is moving along y direction and there is an opposite since there is an opposing force also, so only those velocity which will contribute towards the motion of the direction of the particle, that velocity we will consider. So that velocity is the y component of the velocity. So the y component of velocity is v sine theta. Then theta value it is given to us, it is 30 degree, then it is 20 into 1 by 2, which is 10 meter per second. Now if you put those values, it is s is equal to u square by 2a. So now we need to find out the value of acceleration in the electric field. So we know mass into acceleration equal to force, and that force equivalent to the value of charge into electric field when the particle is subjected to a force in the electric field. So the acceleration becomes QE by m, and then from that we can get the value of acceleration, which is 10 meter per second square. And if you put the value of s, if you take h, then acceleration will be 10, and the sorry, velocity will be 10, and again acceleration will be 10. So it is u square by 2a. So 10 square by 2 into 10, which will give you 5 meters. So this is the correct option, that is the option B. Now we'll move to the next question, question 6. Question 6 says, in the previous question, find the time required for the particle to return back to the line AB after it is thrown from a point. The particle will never, so the options are option A. So let me draw the scenario. So this is A and this is B. There was electric field. So these lines, ideally these four lines should be equally spaced, because we are talking about an uniform electric field. So the uniform electric field is 10 volt per meter. It is acting in downward direction. The particle is projected in this direction with an angle of 30 degree, and u is 20 meter per second. Now the question says, what is the time required for the particle to return back to the line AB? To return back to the line AB after it is thrown from the point A. So it should return to this line AB. Then what will be the time? Options are option A, the particle will never return back to the line AB. So can anyone tell me whether option A is correct or not?
Sir, it is not correct.
Exactly, because since the initial velocity is not infinity, if the initial velocity is infinity, then particle will travel for infinite time. However, here the initial velocity is being opposed continuously by the electric field, whose direction is opposite to the vertical distance or vertical direction. That's why the particle will sometime, after some time, it will eventually return to the ground, that is the line AB. We need to find out that time after which the particle return to the ground. Now the other three options are option B 1 second, option C 1.5 second, and option D 2 seconds. So I'll give you a few minutes to try this question, and then we'll discuss what will be the correct answer. So I'm giving you a hint. So here we will use another equation, that is S is equals to ut plus half at square, because we need to find out the value of time. So we can use this equation to get the time period after which it will come back to the line AB or the ground level. Yes, can anyone tell me what will be the correct option? Or can anyone tell me what will be the values of these unknowns? Because we need to find out the value of t. So t is one of the unknown here in this equation. So we need to find out the time because all the options are in seconds. So it's quite obvious that we will find out the value of time. Also in the question it is given, find out the time required. So now can anyone tell me what will be the value of S, U and A? Yes, anyone? So let me make it easier for you. So now I will consider U is the component of velocity acting along y direction. So uy, because in the previous question also we have considered the vertical component, that is uy, and it is 10 meter per second. So here u is uy, that is 10 meter per second. So can anyone tell me what will be the value of a? Again, value of a is also known to us. We had calculated the value of a was 10 meter per second square. A was 10 meter per second square, but this a, it was negative. So this is negative because it is opposing the motion. So we can modify the equation. It will be S is equals to ut minus half at square. So the only unknown here is apart from t, the only unknown is S. So can anyone tell me what will be the value of S for this question or for the current scenario?
So in y-axis, S will be 0.
Exactly. So S is 0 is the correct answer because if we are considering the vertical motion and we are finding out the time required for the particle to return back to the line AB. So throughout this line AB, the value of y coordinate is 0 because if this is y and this is x, throughout the line of x axis, the value of y is 0. So the distance, if the projectile or the or the object is returning to the ground, then the equivalent vertical distance traveled by the body is 0. So S is 0. So if you put all these values, so S is 0 means half minus half at square plus ut. So it is ut is equals to half at square. Then, or we can say, so another thing. So if here in one way you can just simply omit t from both the sides. So it will give you t is equals to 2u by a. So 2 into 10 by 10, it will give you 2 seconds. So the correct option is 2 seconds. But since this is a quadratic equation, there must be two solutions. So ut minus half a t square is equals to 0. That implies if you take t is common, then it will be u minus half a t equals to 0. So u minus half at equals to 0. This gives us 2 seconds. And again, another answer will be t is equal to 0. Why t is equal to 0 will be another answer? Because the particle is starting from the ground only. That's why at the initial point of observation, that is when time t equals to 0, the particle is at ground level AB, and that's why the time required for the particle to return back to the ground is 0 again, because the particle has not started any motion. That's why there are two answers. But here it is given that after how many time it will return back to the line. It will return back to the line means t is non-zero and the value is 2 seconds. Is this clear to everyone?
Yes, sir.
Are there other students present or only you are present here?
We are here, sir. We are here.
Okay, so also respond na, because the main aim of this session is to interact with you. So
Okay, sir.
it will be better if you all can interact with me.
Okay, sir.
Okay, so again we will move to the next question. The question says question number 7. Question number 7 says in Millikan's oil experiment, a negatively charged oil drop of mass 4.9 into 10 to the power minus 14 kg is balanced by applying a potential difference of 9.8 kilovolt between two plates, which are 12.8 millimeter apart. Find the charge on the oil drop and take the value of acceleration due to gravity g is 10 meter per second square. Options are option A 6.4 into 10 to the power minus 19 coulomb, option B 1.6 into 10 to the power minus 18 coulomb, option C 3.2 into 10 to the power minus 16 coulomb, and option D 8 into 10 to the power minus 18 coulomb. So basically the previous two questions, question number 5 and question number 6, was somehow related to Thomson's cathode tube experiment, because in cathode tube experiment also the point at which the electron or any charged particle hits depend upon the amount of field you are applying, and that amount of field will give you by applying those fields or electric field strength, you will regulate at which the particle is the point at which the particle is striking the screen of the screen of the cathode tube. Uh, However, this question number 7 is based on the Millikan's oil drop experiment, and through Millikan oil drop experiment, the value of charge of the electron was determined. Now, the question similarly, the question says a negatively charged oil drop of mass. So, mass of the oil drop is 4.9 into 10 to the power minus 14 kg. Then potential difference that is being applied between the two plate is 9.8 kV, which are 12.8 mm apart. So the distance between the two plates is 12.8 mm. Find the charge on the oil drop. And the question say, and it is also mentioned it is balanced by applying a potential difference. So it is balanced means the uh, force the oil drop is experiencing due to the mass, because it has some mass. Since there is some mass, it will experience non-zero force, or since it is so earth, since earth has the acceleration due to gravity, or the earth attract everything, so due to the mass it will be coming towards the ground, or it will be attracted towards the ground. However, it is balanced by the potential difference of 9.8 kilovolt between the two plates, which are 12.8 mm apart. So suppose there are two plates here. So this is x axis and this is y axis. So here y is equal to 0 and here y will be 12.8 mm. So between these two plates we are applying a potential difference, and the potential difference between two plates is 9.8 kilovolt. Now the oil drop is balanced here. Suppose this is a oil drop, although it doesn't look like an oil drop, but you have to assume it. So this is a oil drop and the mass of oil drop is 4.9 into 10 to the power minus 14 kg. Now, due to the mass, it will be accelerated towards the ground, that is y equal to 0, with a force of m into g. And if you need to balance that force mg, you need to apply a electric force, and that electric force will be applied between these two plates at y equal to 12.8 and y equal to 0, and the potential difference is 9.8 kilovolt. So can anyone tell me which plate? Suppose this plate is A, this plate is B. So what will be, so here it is mentioned it is negatively charged. So Q is, sorry, it is not G, it is Q. So Q is negative. So can anyone tell me, um, since it is a potential difference, so there are two terminals, positive terminal and negative terminal. So which one is positive terminal, A or B?
Sir, A will be positive.
Exactly.
Yeah,
So A will be positive. That's why it will be getting balanced, because when A is positive, so the field direction will be like that, and it will be attracted towards the, so this is positive and this is negative. That's why it will experience attractive force towards plate A, whereas due to its natural weight it is being attracted towards plate B. That's why when the two force gets balanced, and it is balanced by applying a potential difference. So we need to find out what is the charge, because um, due to the property of the charge, it is getting balanced with a potential difference of 9.8 kilovolt, which is applied between a plate of 12.8 mm apart. So from all these informations, you are expected to calculate the charge of the oil drop.
Sir,
So I'll give you,
option A.
let me see, option.
A.
Yes, option A is the correct answer. So uh, as I have already explained you, so since the oil drop is getting balanced by applying the potential difference, so the weight is balanced by the electric field. Now weight is mg and the electric field is due to the force due to the electric field. Now electric field is V by D. You know the value of B, you know the value of D, and you know the value of V. We know the value of M and G also. So Q will be how much? Q will be mg D by V. So M is how much? M is 4.9 into 10 to the power minus 14. 4.9 into 10 to the power minus 14 into G 10 into D. D होची, sorry, D हो गया कितना? D is 12.8 mm. 12.8 mm. And then V is 9.8 kilovolt. That is 9.8 into 10 to the power 3. 9.8 into 10 to the power 3. So if you solve it, you will get 6.4 into 10 to the power minus 19. 6.4 into 10 to the power minus 19 coulomb. So everybody understood the problem?
yes, sir.
Okay,
So here
so
Yes,
for
sir.
12.8,
sorry.
sir, here the distance is given as 12.8 millimeter. So should we write
Yes,
that
yes, sorry,
10
sorry.
to the power of minus
Exactly.
3?
It will be 10 to the power minus 3. Exactly. So it is 10 to the power minus 3. Thanks for pointing it out. So it will be 10 to the power
Okay.
minus 3, because
Okay.
units are pretty important.
Okay.
So we'll move to the next question. The question is question number 8, and it says, in a millican's oil drop experiment, an oil drop of mass 64 into 10 to the power minus 10 kgs carrying a charge 8 into 10 to the power minus 14 coulomb remains stationary between two plates separated by a distance of 2 centimeter. Find the potential difference acting between the plates where the given value of G is 10 meter per second square. So this is pretty much, this is exactly similar to the previous question, but here the unknown is different. In the previous question, the potential difference applied was given to us, and we needed to calculate the value of charge. Here the value of charge is given to us, and we need to find out the value of potential difference. So I hope it won't take much time. So we will calculate, and after a few minutes we will discuss what will be the correct option. Okay, so can anyone tell me what will be the correct option?
Option D.
Yes, so similar to the previous,
Option
Q V by D is equals to mg. So we need to find out the value of V. So V is mg D by Q. M is given 64 into 10 to the power minus 10. G is 10 meter per second square. D is 2 centimeters, so 2 into 10 to the power minus 2. Then the value of the charge is 8 into 10 to the power minus 4. 8, sorry, minus 14. So if you solve it, it will give you the value of voltage, which is 16,000 volt. So if the two plates are separated by 2 centimeter, we need to apply 16,000 volt in order to balance the oil with a mass of 64 into 10 to the power minus 10 kg and carrying a charge 8 into 10 to the power minus 14 coulomb. So can anyone tell me, if I will increase the distance between the two plates from 2 centimeter to 4 centimeter, how it will affect the potential if you want to balance the oil? Yes, anyone?
no, sir.
Sorry.
It will, it will start to increase.
So it will increase because if you see this formula is a balanced condition. So if you are increasing D, the amount of voltage required will again increase, because unless you increase the voltage, you won't be able to balance the force of the weight of the particle due to the weight of the particle. So if you are increasing the distance between the two plates, you need to increase the voltage such that the electric field remains same, and since the electric field you need to remain constant, you need to increase the voltage, because since distance is increasing, so E is equals to V by Q, sorry, V by D. So if distance is increasing, in order to fix E constant, or in order to keep E fixed, you will increase the value of V. So very simply you can see here, since it is directly proportional to D, so if you are increasing from 2 centimeter to 4 centimeter, you have to also double the potential that you are applying, that is 32,000 volt. So if you are increasing D from 2 to 4 centimeter, the value of voltage applied will increase from 16,000 to 32,000 volt, or 32 kilovolt. So this is the answer. The correct option is option D again, 16,000 volt. Now we'll move to question number 9. Question number 9 says it is a matching question. Match the column 1 with column 2. So column 1 gives the name of the experiments or the name of the hypothesis, and then column 2 gives, or column 2 has the name of the outcomes or the name of the parameter that was determined using the experiments or thesis. So uh, as we had already discussed in the beginning, so Millikan's oil drop experiment, it was used to determine the existence of nucleus or the charge of electron, or it was uh, formulated to confirm that atoms are indivisible. Yes, so Millikan's oil drop experiment gave us an idea about the charge of electron, or help us to determine the charge of electron. And then
Yes, sir.
Rutherford scattering experiment, it gave us the existence of nucleus, because when the scattering experiments are performed, Rutherford found that most of the alpha particles is passing through the gold foil undeflectedly. However, some of the alpha particles are getting deflected, and many and one in a majority amount or very few of them are being iterated back towards the direction where from which they were injected or they were projected. So since alpha particle has a positive charge, because alpha particle is a helium nucleus with two positive charges, helium 2 4. So since it is getting deflected, so it is being repelled by something that is present inside the atom, and that uh, or that region is nucleus. And since most of the alpha particles are getting reflected, it basically reflects that most of the spaces inside the atom is vacant. So most of the amount or most of the positive charge or all the positive charge are concentrated at the center of the atom in a very small region, and that is called as nucleus. So Rutherford's alpha particle scattering experiment gave us the existence of nucleus, or gave us the idea about the existence of nucleus. And according to Dalton's hypothesis, atoms are indivisible. So the correct option, so the matching is option A is
Okay.
3i, B is I, and C is double I. So correct option is option B. So this question, basically this question was pretty much based on the standard informations that you learn in the uh, week lectures. Now we will move to the next question, which is also the last question of today's session. Question number 10 says, a current flowing through an electrolyte is varying with the time as shown in graph below. If the mass of a substance deposited in this time interval is m, then the electrochemical equivalent of this substance is numerically equals to option options are option A m, option B m by 3, option C m by 30, or option D m by 40. So first we need to find out what is the total amount of charge that is flowing through an electrolyte from this graph. So I'll give you a few minutes to think about this question and solve it, and then we'll discuss what will be the correct answer. So if you see the graph, so this is time in second, that is t, and this is current I. So in order to find the total charge, that is the total electricity passing through the electrolyte, we need to find out q. So q is I into t. So how we will get the value of q from this graph? Total charge is nothing but the total area under the curve, because this area gives us the expression q into, sorry, I into t. So this is the total area. So we need to find out the area under this curve or this shaded area. So what is the total area? The total area will be equivalent to total charge passed through the electrolyte. So total charge passed through the electrolyte is, first we will take this area, this triangle. So since it is a right angle triangle, so the area will be half into height into base. So base you can see it is 10, 0 to 10. So this is 0. So it is 0, sorry, 10 minus 0 into here it is 0 and this is 1, so 1 minus 0 plus this square. This square is, the height is 1 and distance is 10, so it is 10 into 1 plus again this is another square of same area, and this is another triangle of same area like this triangle. So these two triangles have same area and these two rectangles have same area, so it is again, so it will be 10 plus half into 10 into 1. So if you calculate it, it will give you q equals to 5 plus 10
30.
plus 10 plus 5, so total 30 coulomb, because amperes into second, that is 30 coulomb. Now q is 30 coulomb. The question says, if the mass of the substance is deposited in this time interval is m, then the electrochemical equivalent of the substance. So we know mass equals to electrochemical equivalent into the amount of electricity. So electrochemical equivalent is equals to m by q. So m by q is 30. Sorry, q is 30. So this is the correct answer. That is the equivalent weight equals to z equals to m by 30. So the correct answer is m by 30, that is option C. Is this clear to everyone?
Yes, sir.
Yes, sir.
Yes, sir.
Okay,
Yes, sir.
so now we have come to the end of today's interaction session. Thank you. I thank you all for joining in today's session. So in the next session, we will again solve a few problems that will be based on the course content of the week 2. So it will mainly cover about the structure of atoms. So we will first discuss about a few things that that are covered in the course lectures, and then we will start solving the problems. So if you have any queries regarding the course, you can ask me also, because if if I can help you, I will definitely try to help you. Or there is a as you all must be knowing again, there is a discussion forum in the course. It is a part of the course. So uh, you can also ask the questions there, and anything related to the live interaction session, you can ask me here, or you can also, if you are not being able to attend also, there is a facility that now all these things that I discussed with you, I will make it a PDF, and then I will upload to a Google Drive folder, and that folder link will be shared with you. And I will try in the next session, I can also I will also display the folder also, and I will also share you the link. And I am also thinking I will share the link in the discussion forum also. So once again, I thank you all for joining in today's interaction session. That's it for my side for today.
Thank you, sir. Thank you very much, sir.
Welcome, welcome. Good night.
Sir, we can get
Night.
all the question that we done today in the Google Drive, right?
Exactly, exactly. All these
Okay, sir.
questions with answers, I will make it a PDF, and I will upload in the Google Drive. And the link of the Google Drive, you will again you will be getting from NPTEL, and also I will post the link in the discussion forum also.
Okay, sir. Thank you,
Okay,
sir.
sir.
Welcome.
Thank you, sir.
Okay.
We'll meet next Monday at the same time from 7 p.m. to 9 p.m.
Okay, sir. Thank you.
Okay.